So for those of you who haven't been on my yesterday's presentation, I'll waste 30 seconds telling you who I am. I started with networking in the good old days when we had IPX and AppleTalk and DECnet and X25. Anyone here who has been actively working with X25? Apart from you, you don't count. And then I was deeply involved in ISP business, so I was running the first commercial ISP in Slovenia in '92 or something like that. And lately I'm blogging and doing webinars on technologies, try to be vendor independent or at least neutral. And I'm focusing on exciting new stuff like data center technologies, and this is what we'll talk about today. So the first thing that I have to mention is that I will talk about real life solutions. I will not talk about futures. I will not talk about vendor promises. I will talk about what's available today. And I will mention a few companies, and if I mention a company, it doesn't mean that it's good or bad. It just means that I happen to know what they're doing, and they fit the picture of what I have to tell you. So it's not an endorsement, it's not bashing, unless I tell you something is really bad, in which case it's bad. And as I said, I'll describe features and not futures. And this is a famous quote that I really love. So, is anyone in here a server admin? OK, now stop listening, please. Server admins are always complaining how networks are causing problems. And one of the most famous quotes from this guy from Amazon is, data center networks are in my way. They're stopping me from doing business. And well, I have to agree with him. So this is probably like the first time a networking guy is saying a server guy is right. And the question is, can we do any better? And of course, every vendor is telling you that their particular fabric solution with their particular awesome sauce is better than anything else, and it will solve all the problems in this world and bring the world peace. So let's try first answering, why does it matter? It matters because everyone is rolling out cloud services to start with. And it matters because something like 80% of the traffic tends to stay within the data center. So previously, we were running self-contained servers that would serve content to the customers. So all the traffic would go, as they call, south, north-south, from the server to the user or the other way around. Today, you almost always have an application stack where you have web server on one machine, application server on another machine, database server on a third machine, and storage somewhere. And so most of the data goes between nodes in the data center. Microsoft did a research paper a year or two ago, and it's really worth reading, where they claim that something like 80% of the traffic stays within the data center. So it does matter. And the other problem is that with cloud computing, everyone wants to have everything deployed now. And they want to have it deployable anywhere in the data center. So I need to spin up a new VM. Well, I'll just pick a server that is the least busy, and I'll spin up the VM on that server. Oh, you need a VLAN. Too bad. I want a VLAN now. OK? Familiar? Good. And everyone wants to have unlimited virtual machine mobility, which makes absolutely no sense, by the way. VM mobility makes sense in a limited environment. VM mobility around the globe, for example, makes absolutely no sense. And if someone disagrees with me, I'm very happy to take this offline and discuss it with you. So, do fabrics help? And actually, what is a fabric? So when I was preparing one of my data center fabric webinars, I looked at the marketing materials from 3 different vendors, tried to extract what they think a fabric is and what characteristics a fabric could have. And as you see, there is no overlap at all. So fabric, by definition, is whatever my gear is doing today. OK? That is not helpful. So what do we really need? From the server guy's perspective, what we actually need is something that will give me equal bandwidth between any 2 points in a limited domain. I mean, someone will ask you for equal bandwidth between any 2 points in the data center, which is plain stupid. I can do it, but it's too expensive. But realistically, equidistant endpoints with non-blocking core is something that makes perfect sense. Can we deliver that? Actually, we can. And the other things that people should be asking for is lossless transport, because that makes absolute sense for what they call elephant flows, like storage and backup. So those two things absolutely need lossless transport. Otherwise, a single TCP packet drop will drop the performance by half, which is unacceptable. And we would want simplified provisioning and management. So these are all things I can absolutely agree with, and I'll tell you how you can build networks that have these capabilities. Using low-cost existing gear with no future technologies like Trill, and with no unicorn tiers. Okay? And the questions you have to answer is, do you want layer 2 or layer 3 transport? And does it matter? And for those of you who have been on the cloud networking presentation yesterday, I've told you how you can actually do virtual networks over layer 3, over IP. And that makes perfect sense, because then you can build your data center in the same way, regardless of whether you will run infrastructure as a service, or a Hadoop cluster, or whatever other big data application, or your web farm, or whatever else. You use the same technology, the same boxes, the same solutions to build large-scale layer 3 transport. Okay? And do we need Trill or SPB or Fabric Path or QFabric? Actually, unless you insist on very large layer 2 domains, which don't make sense anyway, you don't. And the vendors don't like me saying that. And we solved this problem by going back 60 years to the domain we all hate, the voice networks. Because those guys had the same problem. They had to build these huge voice switches, and the switching elements were too small. So this guy, Charles Claus, very smart guy, wrote a research paper in 1953 saying, hey, by the way, I can build a really large fabric with small elements if I just wire them together correctly. And this is exactly what we should be doing in the data centers. And by the way, this is exactly what every single vendor of high-end switches is doing internally. And then they claim they have some secret sauce. They're all doing this thing. And if you do this right, you have to have non-blocking switching in the core, so these elements have to be non-blocking. You could have non-blocking end-to-end, which doesn't make sense, because a server usually has 2 uplinks for redundancy, and they're both 10 gig, so you can combine storage and data over the same links. So a server has 20 gig of uplink bandwidth. It will never push 20 gig out through those links. Never. So oversubscription at the edge makes sense. Oversubscription in the core is bad. You want non-blocking core. And by the way, this is what I'll show you is not a truly non-blocking architecture from academic perspective, because it relies on load balancing. And load balancing is based on statistics, and you can always get it wrong. The people that get load balancing the least wrong is Brocade with their VCS fabric, because they can actually balance a single flow over multiple links, because they have technology from Fiber Channel where they actually delay some packets so that they still arrive in sequence, even though they traverse multiple links, which sounds like a miracle until you realize what they're doing, And it actually works. And it works well. So this is not, from the academic perspective, a true non-blocking architecture, but it's good enough for the regular use. The only time when this can hurt you is if you have a small number of very large flows. Then you might have a problem. Anyway, generically, what you do is you take some high-end switches, like core switches. You take some top-of-rack switches. And the trick is that you connect every top-of-rack switch, or the leaf node, as they are called, to every single core switch, to every spine node. OK? So you see that you have 4 different paths between every 2 switches in the network. OK? And you can load balance between them. So from any ingress switch to any egress switch, you have the same aggregate bandwidth. Now, obviously, this doesn't work if you put spanning tree on this. OK? So this works with layer 3 fabric, or it works with one of those odd things that I've mentioned, like trill or SPB. You have to have equal cost multipathing on every step. Okay? And if we talk about layer 3, the question is, where do we do the lookups? You could do full lookup at every hop. So every hop would have full layer 3 routing table and do full lookups. Or you could have layer 3 switches here that would only have the ARP table, so the host routes, and default route pointing into the core. And the core switches would have no host routes, no ARP tables. They would only have the prefixes assigned to these endpoints. That scales nicely. Or you could do something like Juniper, where they actually do a single layer 2 or layer 3 lookup in the queue fabric. And I'll show you later on how that works. And then the packet traverses the whole fabric without additional header lookup. What they do is they do the first lookup at the edge. They figure out the path the packet should take. They attach a label. It's like MPLS. I mean, Juniper is known for good MPLS implementation, right? They will not admit it's MPLS-like. It's totally different. But it works like MPLS. And it works well. So Brad Hedlund, that moved from Cisco to Force10 a few months ago, provided me with these pictures. And this is his case study. And then I just took Arista's datasheet and this. So what he did was he had 4 core switches, then a number of top-of-rack switches, 32 in his case, and 4 uplinks, 4 times 40 gig uplinks. Now, when I was sending him this presentation, he said, well, you know, be careful about this, because if you have 40 gig uplinks, you're limited to 100 meters of cabling. And can you really pack this many servers within a 100-meter radius? And will your cooling survive that density? So be careful. Anyway, with 36 switches, he got 1,500 equidistant ports. And these are low-cost switches. These things are like pizza boxes. Force10 is good at making pizza boxes. Really good. Arista, they have this giant core switch with 380-something 10-gig ports. So in the same configuration, I could use, I don't know how many of these ones. Oh, 380 switches. I got 18,000 ports at 3-to-1 oversubscription. So you see, I can build a data center with a block of 9,000 servers with dual uplinks, and all servers are equidistant. Okay? I just need 16 core switches. Okay? So don't tell me it can't be done. Are you willing to pay for it? That's a different story. I mean, even Arista switches are not that expensive. And by the way, Brad sent me another interesting comment to this presentation saying, you know what, we could do like split class fabrics, where we have 4 different class fabrics and top-of-rack switch linked to all 4 fabrics, and I could get to 25,000 ports, just in case someone needs that. Layer 2 is a bigger problem. And here, you either go with one of these new technologies like SPB or Trill or Fabric Path or whatever, or you go with someone who has giant core switches like Arista does. So with Arista's core switches, and I used only 2 of them because you can't combine more than 2 switches in a multi-chassis link aggregation group. So I'm limited here to 2 core switches. I could use 45 top-of-rack switches, and some ports are used for lap links, and some ports are used for inter-switch links, and so on. I got to almost 2,000 layer 2 ports at less than 3-to-1 oversubscription. Now, does this make sense? No. Absolutely not. Layer 2 domain is a single failure domain. Okay? So one VM goes crazy, and those broadcasts are flooded across all ports. All servers go down. That's great, isn't it? So never, ever do a huge layer 2 domain like this. Because yes, you will get away from spanning tree, because here, this thing looks like a star. It's not actually a graph, because we are using link aggregation here. So yes, we run spanning tree just for safety reasons, but it actually doesn't block any links or anything. So spanning tree will not kill you, but the broadcasts will eventually, sooner or later. Or a stupid customer will, because he will bridge between 2 NICs in his VM. I've seen that being done. It's not a nice view. And when you do something like this, check the table sizes in the core switch. Some of these core switches might not support as many MAC addresses as you need. Because with 2,000 server ports, that's like 1,000 servers. 50-to-1 or 30-to-1 VM to server ratio is 30,000 MAC addresses. That's how many MAC addresses you need to store on these core switches. Okay? Check the data sheets. I will not mention any numbers. By the way, the authors of the Trill standard are not as stupid as some people who build huge layer 2 domains. And they put in the standard that it makes sense to have around 1,000 hosts in a single bridge LAN. Okay? Which I totally agree with. Now, imagine that you have the most common configuration where you have every VLAN enabled on every server port, because that's just the simplest way to do it. Okay? The server people don't want to talk to the network people. They don't want to ask for a new VLAN. So you just enable all VLANs on all ports. OK, we're done. You've effectively turned the whole network into one single broadcast domain, which means that the whole network supports something like 1,000 hosts reliably. You've just limited the scalability of your network with this wise decision. OK? Because every server will get every broadcast over every uplink. And yes, it is in the wrong VLAN. But do you know that server NICs run in promiscuous mode if you run VMware or any other hypervisor? Which means that every server will have to process every broadcast and figure out that he's not interested. And that will kill you. Other reality checks, VMware high availability cluster can have up to 32 hosts. And if you go with VMware's distributed switch, the maximum vMotion radius is 350 hosts. That's the absolute maximum where vMotion makes sense. So more than 300 hosts in a single layer 2 domain is plain stupid. Okay? Whenever someone asks you to have the same VLAN across the whole data center, show them these numbers and ask them why they need those stretched VLANs. What are they planning to do with them? But it would be nice to have. Yeah, sure. Nexus 1000V, by the way, can only span 64 hosts. So if you use Nexus 1000V, the vMotion domain is even smaller. And you can't vMotion between VDSs. That's a major pain. You can't. So if you want to build larger networks, instead of 3-stage fabric, you go to 5-stage fabric. The core is the original 3-stage fabric, fully meshed. And then the edges connect to just few of the core switches, not all of them. So you see, yet again, you have the same bandwidth with any pair of edge switches, but the number of links in here is smaller. Okay? Now, with this architecture, and by the way, this picture is identical to this one, only I cut it in half here and folded it over. Okay? You got it? Good. Now, the same thing as before, 16 middle switches, 32 stage 2/4 switches. That's why we need 32 here and 16 here, because actually they're 3 times 16. And the top of rack switches. Yet again, using those same pizza boxes I was mentioning before, you can get to 6,000 something 10 gig ports on layer 3. Layer 3 only because 4stan doesn't support anything that could help you build layer 2 fabrics this big. Not that it would be a good idea. I've seen a design from Cisco with Nexus 7000, Nexus 5000, Nexus 2000. What is similar to this? They easily got to 18,000 equidistant 10 gig ports with 3-to-1 oversubscription. And the oversubscription was only done on Nexus 2000, on the fabric extender. So the Nexus 5000, which was like the first, well, the second stage here, Nexus 5000 had half of the ports being used for fabric extenders and half of the ports being used for uplinks. So it was totally non-blocking. And they got to 18,000 something ports with reasonable cost for 18,000 ports. And then we have QFabric, which is exactly the same thing I've shown you on the previous slide, only it's well hidden and nicely packaged. The fabric interconnect is actually a 3-stage class fabric. With the top of rack switches, we have a 5-stage class fabric like the one on the previous picture. That's all QFabric is. 3-to-1 oversubscription because you have 48 edge ports and 4 40 gig uplinks on the QIF nodes. The only beauty, and this is the real beauty of QFabric, is that they have central management plane, so you configure all this thing as one entity. It has one configuration. It has one set of SNMP counters. You monitor this as one giant switch. And you can monitor through that same SNMP IP address. You can monitor any utilization on any port in the whole fabric, which is cool. And luckily, they got it right, and they don't have a single control plane, because that would never scale. So they have like dump control planes in the individual switches that can do forwarding and spanning tree detection and LACP and LLDP and those simple things. And they have complex control plane in the director, which can run routing protocols and things like that. So it's a truly distributed architecture. So it does scale to the numbers they're promising, which is 6,000 something ports. And it appears as a single management entity. Added bonus, they do one single entry point lookup, which means that this switch, for example, does layer 2 or layer 3 lookup, whatever it is, decides what the egress port is, and sends the packet across the fabric to the egress port. Now, this nicely solves the next layer 3 next hop gateway problem. because you configure one IP address for the router, okay? And it's shared by all the edge nodes. And the MAC address for the router is shared by all the edge nodes. So no HSRP, no VRRP, nothing like that. You move the virtual machine around, and it's always directly connected to the next hop router. Not only that, you always have optimum traffic flow, because the traffic always goes from the entry point to the exit point. It never goes off to a layer 3 device and then back. Okay? You get optimum traffic flow across the fabric every time. So, I hope you believe me by now that yes, we can build large-scale fabrics with existing equipment, with no new technologies, no awesome sauce, and no unicorn tears. Okay? And these things have been tested, and these things have been used for years by people like Facebooks of the world. This is not something new. Why do you think Facebook is one of the biggest customers of ForceTen? They like the pizza switches. And keep your layer 2 domain small, and if someone asks you to build huge data center with virtual networks, consider things I've been mentioning yesterday: VXLAN, MVGRE, or Nicira. All three of them do bridging over IP, which scales because the core stays IP. And we know that IP scales. After all, we build the internet. Okay? And there is actually no need for emerging technologies like Trill or SPB unless you want to build huge layer 2 domains, which, as I said, don't make much sense. You need more information. I have a whole range of webinars. Just go to my website and figure out what I have. And that's it. So any questions are most welcome. No?
So with all this direction of making a number of devices appear as a single entity from the management standpoint, it also increases the risk of like a human error in configuration. So, you know,
Absolutely.
Instead of configuring one device, you may actually reconfigure the whole fabric by accident.
Absolutely agree.
What do you think? Where is the balance? Like, should we, you know, should we consider centralized approach to management, or try to enforce policies using some automation tools?
Well, as they say, this is a really good question. Hopefully, we will use more and more automation tools. And I would love to see the networking vendors slowly doing more and more auto-provisioning. And every single vendor claims that he is doing auto-provisioning and zero-touch provisioning and I don't know what. And actually what everyone is doing is they're using DHCP to get the IP address for the box. And then in the DHCP response, hoping they will get a URL that will tell them where to download the configuration from, which is not auto-provisioning in my book. The only ones that I've seen so far that do something really smart is Brocade with VCS Fabric, where on a new switch, you have to type in, yes, I want to join the fabric, okay, which prevents the VTP beauties that we all love to hate. You know, VTP was the first attempt, you know that. And it was way too aggressive, so a new switch could just bring down the whole network. So Brocade did the right thing. There you have to say in the switch, I want this switch to join an existing fabric. And they say, well, you know, but this will erase the switch configuration. You want to proceed? Yes. And then they figure out automatically what the uplinks are. They figure out automatically how to bond links belonging to the same link aggregation group. Because after all, if I'm receiving LLDP packets from the same neighbor over multiple links, hey, why shouldn't I configure them as link aggregation group, right? And because they're working on layer 2, they don't have any layer 3 yet, they actually allow you to just plug in a new switch, and it's more or less auto-configured, and off it goes. Okay? I don't have any feedback on the operational experience of anyone with QFabric. So I don't know how much the fat fingers will hurt people. But yes, you're right. It's a big risk. Does that answer the question, sort of? Okay. Yeah. Any more questions?
Yes, I do have one.
Mm-hmm.
1 second, I will mic from microphone. But my question is a little bit not touching maybe data centers, but we have a large L2 network aggregating all the subscribers which are like DHCP subscribers or PPP over Ethernet, which go to the central BRAS. Mm-hmm. There is, at the moment, I think about 12,000 of MAC addresses in the central switch, which I see. What kind of solution in the future you think? Because, I mean, there is like a maximum several hundreds of subscribers per VLAN. And we don't do such a thing like towards some subscriber or some point we provide all the traffic of whole VLANs, so we don't distribute broadcasts everywhere.
Yeah.
But what kind of solutions in the future? I mean, at the moment we can't afford to buy MPLS.
Okay.
That would be the best, I think.
Well,
at the moment.
The first important question is what is attached as the CPE? Do you have your own CPEs that you control, or do you just extend that thing to the customer premises?
I mean, usually there are some Ethernet switches, subscriber aggregation switches, which are, or access switches I would call, which are just managed by ourselves. Mm-hmm. CPEs are only in GEPON solutions. Mm-hmm. So mostly it's like a subscriber gets a VLAN, mm-hmm. Which is shared, like the broadcast domain is like several tens or maybe 200 of subscribers maximum in one VLAN.
Well, you see, the important question is whether anyone is providing broadcast isolation. Because if your CPE device mm-hmm. is a layer 3 device doing NAT, for example, mm-hmm. then the broadcasts in the subscriber's home will never escape into your wide area, well, into your access mm-hmm. network. So you will only see ARPs, and you will primarily see ARPs for the next
from CPE.
From CPE, and so that is survivable. Mm-hmm. Okay. The moment you allow the subscribers direct access into the access network, a single PC going crazy could start sending broadcasts to all the subscribers. And yet,
so that's why what we do is we are trying to limit as much as possible the number of broadcasts that are I mean number of hosts per VLAN.
Exactly.
Which is possible with the BRAS that we use. Mm-hmm. And the other thing is that, for example, GPON is not a problem because they separate the traffic between subscribers.
Yeah.
I mean, they can go only with proxy
GPON
ARP.
Is actually like private VLAN.
Yeah, you have to have proxy ARP to be able to communicate between hosts. So you have a control. So
and the other thing, what?
I mean, if you mentioned maximum 1,000 of hosts per I don't know, it was a VLAN or per VLAN. Yeah. So this same number will be suitable for subscribers also, or should be much lower?
As I said, it depends on whether you have layer 3 isolation at the edge.
We don't. Let's say we don't.
Then it's a problem, because if the number of broadcasts between routers, mm-hmm. if you wish to call CPEs layer 3 CPEs routers, is very small because it's only ARP. Mm-hmm. Whereas the moment you extend a VLAN directly into the customer's home, the number of broadcasts is way higher. Plus, there are security issues because someone who is not using a firewall is wide open to everyone else, so it's not a good idea anyway. As for the number of MAC addresses, if your CPEs would be layer 3 boxes, then obviously you would only have one MAC address per subscriber, which also limits.
But it's mostly like if subscriber has just one computer, he's connected directly to L2. If he's got more computers, he will get the router CPE. So then we have the L3
well,
isolation.
Can at least your GPON modem limit the number of MAC addresses per port? Because that would help you prevent some of the denial of service attacks. Right now I'm thinking, oh gee, what? I don't even want to mention all the things I could do on your network.
I mean, you could just try to generate as many source addresses as you wish.
Exactly. For
then,
example.
Then to make the network to flood all the traffic to unwanted places.
Yeah.
This happens. I have some in Central Point. I have some. I mean, happens, but I don't know what's the reason for that. I can see probably it's a problem of the switch.
Well, anyway, the first thing you want to do is you want to figure out how to limit the number of MAC addresses a subscriber can have. If you can do that on the GPON modem, that would be great.
And monitoring of the level of the broadcasts per domain?
Well, yeah, I don't think you can do that per VLAN.
I could put all the VLANs to one port, which is like a monitoring port, and start
you could do that.
TCP dump.
Yeah, you could do that. As for reducing the number of MAC addresses, well, the first thing you should do, obviously, is to prevent the subscribers from generating them. The only other thing you could do is you go to some sort of encapsulation technique, and it is like either provider backbone bridging or MPLS.
Next steps.
That nothing else will save you.
Okay, so that's in the future. Okay, or if some nasty soft. The biggest problem is that subscribers mostly they don't do it, but some malware can do it.
Exactly.
For them.
Yeah, exactly.
Okay, so similar problems for access networks, subscribers,
of course,
data centers.
Of course.
And it's
always the same problem.
I think our situation is quite common to many networks in our country.
Absolutely, not just in your country.
Okay, thanks a lot.
Thank you. Anyone else?
Are there any more questions?
There's one. What did I say wrong?
I would like to put one comment. Just one comment, Ivan. Do you agree then that from this discussion you had just a couple of seconds ago, we can say that VLAN extension plus some sort of security is a solution which is not bad actually, but is good enough?
Well, what are you trying to sell here?
What I'm trying to say is that...
Okay. I sort of agree with you with a but. If you have layer 3 devices attached to layer 2 access network, then yes, I agree with you, that is good enough.
And you manage them.
And you manage them so that someone cannot do RA attacks or ARP spoofing or something along those lines. Or if we move into the enterprise space, if you're selling someone VPLS services between 50 sites, and he attaches routers to the VPLS cloud, I'm perfectly fine with that. That's a very limited domain. No broadcasts go in and out. Routers provide security perimeter. But if someone uses layer 2 switches to connect to the service provider access network, then they will have problems. You agree with that?
Yes, I agree, but
Perfect.
Without security. If we add a security level, even on the layer 2 switches, then we can limit the problem as well.
Well, the problem with, if you extend the single VLAN, which is what you're doing here, between multiple locations, then someone who hacks into one location usually has access to all the other locations. On the switches, you can limit the number of MAC addresses.
Or do private VLAN and
You can do that, yeah. So in the internet access scenario, you could do private VLAN, and then every subscriber would only be able to talk to the router.
And the other subscribers via the router.
Yes, and then in the router you control something or you don't. That's up to you. But in the enterprise case, what I mentioned before with VPLS and switches at the edge, the problem is that someone who hacks into your remote office immediately gets access to everything else that is in the same layer 2 domain, which is a problem.
Yeah, this is a problem. But if we add additional broadcast storm, for example, on the access layer switch, then...
Well, that prevents broadcast storms from going out. It doesn't prevent ARP spoofing.
Yeah, that's correct. That's correct.
I mean, if I would hack into a location, I wouldn't go and do a broadcast storm because then I would be discovered in the next 30 seconds. I would do some reconnaissance first, listen to ARP requests, figure out who is who, then do some ARP spoofing, intercept some traffic, shuttle it out, analyze it. I would never do a broadcast storm. That would be plain stupid.
Yeah, definitely we need dynamic ARP inspection and additional security level. Yeah.
Well, but you know, you get all that for free if you use routers.
Yeah, that's fine. But switches are more cheaper than routers, so you can.
Are they really?
So far, yes.
Okay, I sort of disagree.
You mean really
Well,
like,
what type of switches? Let's define first what type of switches we're talking about.
Not MPLS, of course.
No. I mean, the pizza boxes from Force10 are pretty cheap, and they're usually layer 3 switches.
Yes.
What do you mean by 3DP?
Well, I know. I don't have their price list, but I'm pretty sure someone in Poland is selling Force10, so go talk to them.
But mostly as access devices,
Yeah.
you use something which is not doesn't cost more than 150 euro per switch.
I don't want to discuss this. Now, for reasonable access switches, go talk to him. Because particularly in the IPv6 space in carrier Ethernet, you will get very interesting problems if the first hop switch is not layer 3. So there are a number of security implications in IPv6 because it's a bit different than IPv4. And the best way to solve them is to have the layer 3 switch as the first hop switch. Okay?
I'm afraid we are running out of time. Yes. I'm sorry.
So we'll discuss
Thank
this
you.
over lunch.
Thank you very much for your presentation.